Hello there, Cougar Academy, Algebra 1B, and welcome to Lesson 9.5. Today, some special factoring patterns, and hopefully you come to see that these are pretty darn neat. So, difference of squares, that is our first factoring pattern, and what it's going to look like is if you have a perfect square and you subtract another perfect square, okay, that's going to become the square roots of each of those, one of them plus and the square root, and one of them minus and the square root. That's going to look very confusing right now, but hopefully you come to see what it will be through some examples. What I mean by perfect squares are numbers like 4, 25, 36, 9, 1 is even a perfect square. And where I'm getting those numbers from, they are numbers that multiplied by themselves are another number. So when we look at finding perfect squares, if you're not sure, in your calculator, if you'd go under graphing, y equals, and you do x squared, and you go to the table, these are all of the perfect squares of numbers. So 16, 25, 36. On the left are all of their square roots. So I think it's helpful, especially if you don't know all of your factors, to know this trick in the calculator and know that when I'm talking about square roots, those are 1 and their perfect square is 1. 2 is 4, 3 is 9, 4 is 16, and so forth. You should hopefully know up to 100, but I know everyone does not. So anyway, what we are doing when we recognize that we have a perfect square, when you have something such as p squared, that is a perfect square. Okay, so perfect square. And 16 is also a perfect square. And the key thing here is it's a difference, so it always has to be minus. When you notice this, you can simply write down, okay, p plus 4 and p minus 4. That is the factor. Those are the square roots. Remember, 16 is the perfect square and 4 is its square root. And if you don't believe me, you can try factoring this, or FOIL, and we'd have p squared and minus 4p and plus 4p and minus 16. And lo and behold, those cancel, and we have p squared minus 16. So difference of squares, you can just jump right to plus and minus the square roots. Another example here, so 36. I look at 36 in my calculator, and I see its square root is 6. So you could have p minus 6 and p plus 6. Remember, it does not matter which side the minus and plus is in for these ones, since they're the same numbers. And there you have it. That's the answer. For number 3, 1, it's a little sneaky, but it is a perfect square. So I like to draw this when I notice the perfect squares. That just tells me I have a perfect square pattern, x plus 1 and x minus 1. That is the perfect square of 1 and square root. What you have to be careful with is number 4. This does not work with plus. So this is actually a trap. Careful. It is not the special pattern. It only works for subtraction. So this example is actually unfactorable. Okay, I am going to warn you, there are some questions in the practice that are plus, and typically that's a common mistake as students see the square and just want to break it up. So you actually just write unfactorable for that particular case. Only works for minus, only minus. Now, another example is perfect square trinomials. And these, you're again going to notice we have a perfect square, we have a perfect square. In between, it could either be plus or minus. And this is going to be 2 times the square root. Now, really, these ones you can just kind of think about a little differently. If we remember our old factoring skills, we can think of negative or of 1 as negative 1 times negative 1, multiplying those equal positive 1, and they also add to negative 2. So this would actually be r minus 1 and r minus 1, which you can actually represent as r minus 1, the quantity squared. So that is what's special about it, is they are actually the same factor twice, and you can square it. Looking at another example, so 14 and 49, I would start by thinking about 49. That's going to be 7 and 7. And check that when you add those, they equal 14, and they sure do. So we have x plus 7 and x plus 7. We can rewrite that as x plus 7 quantity squared. So you could leave it technically as the other expression right there, but go ahead and get used to expressing it as the squared binomial. Okay, so that's the main idea. There are some practice questions there for you. Be wary of unfactorable expressions. There are some out there trying to trick you. So please practice those and let me know if you have questions.